Hello, middle school math students. This is our second lesson on the math practices. Today we're going to cover math practices 5 through 8. This warm-up is mostly for students in 8th grade. We will cover this in 7th grade, but if you're in 7th grade right now, that means you haven't had this lesson yet. So this warm-up is for 8th graders. Solve the equation negative 6x plus 2 is equal to 26. We're going to pause the recording as you take the time to get that done. Okay, only continue watching if you've already done the warm-up for yourself. It says to solve the equation. When we're solving the equation, that means there is a variable, an unknown, and I'm trying to figure out what that unknown could possibly be. So the way that I taught this last year when you were in 7th grade is we need to figure out what's happening to x so that we can undo it. We think of it as putting our socks and our shoes on and then taking our shoes and our socks off. So let's take a second and identify what are the things that happen to x. Here's our x, there's our variable that we're trying to find the value of. What are some things that happen to x? Bethany? Yeah, it's being multiplied by a negative 6. And after it's multiplied by a negative 6, then what happened to it? Adia? Yeah, we added 2. All of those things are what happened to x and what changed the value to 26. So now I need to change it back. And that means I'm going to undo adding 2. How am I going to undo that adding 2? Evan. Yep. And when it's time, how am I going to undo multiplying by a negative 6? Ryan. Dividing by a negative 6. You know those things, you're going to be just fine in solving this equation. Because those are the changes that happen to x. We're going to unchange it. We're going to undo each of those things. And so I'm going to get started by following that first step. Says the first thing I need to do is I need to subtract that 2. Now, we think of these as those balanced scales like we saw before. So if I'm going to remove 2 of something from this side, then I have to remove 2 of the same thing from the other side. That way it's going to keep it balanced. And 2, removing 2, well, that's gone. That zeroes out. It means I still have this negative 6x, and it is equal to 26 minus 2, and that simplifies to 24. Our next step then, we've already subtracted 2. Now it's time to undo the part where I multiplied by a negative 6. So now I need to divide by a negative 6. And again, since I'm undoing this by dividing this side by a negative 6, now I balance it by dividing the other side by negative 6. Again, that has been undone, and that leaves me with just x. And x is equal to 24 divided by negative 6, which is negative 4. So what should you have typed into your calculator for your quick pull? X is negative 4. I'm asking you to solve the equation. I'm asking what is that unknown value, so you need to tell me this unknown value is equal to negative 4. All right, students in class discussed what their mistakes were, and we're going to readdress those later on as we continue on with this lesson, which is the 8 standards for mathematical practice. So to review some things from our last lesson, we talked about the 8 standards for mathematical practice are just how good mathematicians do math. We made a circle map of all the things that we think good mathematicians do, and I want to show you how many of them have already been addressed in math practices 1 through 4. Showing work, that's math practice 3, also part of math practice 4. Don't give up, that's perseverance. That's math practice 1. I think trial and error can a lot of times be part of math practice 1, making sense. Give it a try, see if it works. If it doesn't, then that's okay. Working hard is perseverance, that's math practice 1. Making mistakes and learning from mistakes, I think that that's kind of part of math practice 1, making sense. It's part of math practice 3, constructing viable arguments, critiquing your reasoning. Sometimes maybe you need to critique your own reasoning and not someone else's reasoning. I think that approaching these things with confidence and a growth mindset, that is all what is going to help us with that perseverance. Understanding the problem, that's literally math practice 1. Use models, that's math practice 4. Just in the first 4, look at how many of these we've already been able to explain, or how many we've already addressed. There's probably more. So math practice 1, make sense of problems and persevere in solving them. Math practice 2, reason abstractly and quantitatively. Math practice 3, construct viable arguments and critique the reasoning of others, or as I like to remind you, show your work. Math practice 4, model with mathematics. If you're stuck, show a different way. prove it by showing it another way. And now we're ready for Math Practice 5. Math Practice 5 is use appropriate tools strategically. Now, I usually will talk about this math practice when I remind you that maybe you're not using your tool appropriately. And so I think that that is kind of related part of the behaviors of class, but I want to talk about what it means to use appropriate tools strategically. First, before we even read this and come up with our own words, can you please list as many math tools as you can think of in that circle map? I'm going to pause the recording and give students in class 60 seconds. Give yourself 60 seconds to write down as many as you can as well. Pause the recording now. All right, your time is up. We are going to come back together as a class, and I'm going to have you guys once again, I'm going to have you just shout out, waiting long enough between call outs for me to write it down. So, what are some math tools? Brain is a math tool, yes. Calculator. Sorry? How about, let's say, background knowledge? Would that count? It's how you're thinking about the subject based on the things that you already know? Scissors? I don't know. Sure. Scissors. Protractor? Compass. Sorry, there was something said I didn't hear or understand it though. Pencil, yes. I'm going to add paper to that. Paper and pencil. So different strategies like color coding. I think we're covered here. Ruler. I'm going to say not just tiles, I'm going to say manipulatives, all sorts of manipulatives, whether it was base 10 blocks 3 years ago or our algebra tile manipulatives this year, right? So let's just call them manipulatives. Whiteboard. Yeah, your fingers. Sometimes we still are skip counting and using our fingers to keep track of that, right? Our fingers are still a math tool. Highlighters. Yep, I think we get the idea with whiteboard. Thank you. Pictures. What do you mean by that? Okay, so pictures or diagrams that might help with our understanding. Could a meter stick be a math tool? Could a yardstick be a ruler? Or be a ruler? No, it cannot. But can it be a math tool? Probably. I don't think a reward system. I think that's a behavior management. No one has mentioned this. Laptop. Yep. Okay. So we get the idea about all these different types of tools that could be helpful for us. We have now considered the available tools. We need to make sure that we're also sufficiently familiar with them so that we can make good decisions about when each tool might be helpful, recognizing both the insight to be gained as well as the limitations. Use tools like technology or manipulatives to explore and deepen the understanding of concepts. So, what can we say about Math Practice 5? It really is all about using tools to make sense of math. But part of that is knowing when to use the right tools, what those right tools are, what those limitations are. We actually had a problem. Was it last year, or is it a problem that I'm going to do with you guys this year in 8th grade? I can't remember now. A student was trying to measure a football field with a meter stick. What challenges? So are meter sticks designed to measure? Yeah. What challenges would you have with measuring a football field using, we can even say yardstick, because I know you guys are going to say it's measured in yards, not meters. So a meter stick or a yardstick, what are some challenges that we're going to have? Adia? Yeah. So it is a great tool for measuring things, but the size is a limitation. What would be a better tool that we could use to measure a football field? Landon? How do you measure it with the computer? If you, I could make an argument for a computer using Google Earth. Okay, so something like that. So you don't even need to take the computer to the football field. You can just use it using, or measure it using the computer from a distance, right? Okay, Bethany. But you're the one who has to paint those measurements on the field. Uh-huh. Yeah. Now it's more challenging, right? Braden. 2 meter sticks. What are some challenges we're going to have if we have 2 meter sticks? It's even, so watch this, watch this. If I'm using a meter stick, there's one, I pick it up and I move it again, and there's another, and then I pick it up and I move it again, and there's another, and then I pick it up. And what's happening as I'm slowly doing this? Yeah, is it a straight line anymore? No. And so we're still going to have some issues. What is a better tool to help measure a football field? Do you guys know the name of the tool? I don't know the name, so I'm hoping you do. Ryan. A super long measuring tape, yeah. I think they have, the ones that roll on the ground? Rollometers or whatever. I don't know what they're actually called. Yeah, what are they called? Rollometers? Let's call it a rollometer. Yeah? Rollo measure. I don't know. Okay. Yes, Jason. A 100 meter stick. And I'll just go ahead and pull that out of your pocket. You got it just stored in the closet, right? Yeah. Okay. So, voices off. Come back to me. Use appropriate tools to strategically is what insight can be gained, as well as what are those limitations. Choosing the right tool for the right job. So if I asked you to do 3 plus 7, what's going to be the best tool for that? Your brain? Your calculator? Or fingers? I think at this stage, is it still your fingers? Are you still going to use your fingers to do 7 plus 3? Or is that something that's just in your brain? Now, a second grader, would they still maybe need to use their fingers? Yeah. So understanding, thank you, understanding that there are different tools available that can do the same job. It's choosing the appropriate one, being very strategic about which tools we're using and when. We're going to move on to Math Practice 6. I love Math Practice 6. We had some mistakes in our warm-up because we weren't following Math Practice 6. Math Practice 6 is attend to precision. Now, precision, yes, we think about being right. We think about accuracy. But I want to talk about the deeper meaning of precision. Attend to precision is about communicating precisely to others. We have to use explicit definitions in discussion with others and in our own reasoning, explicit definitions. Know the names of symbols used. So what's the difference between each of those? Obviously, you could say, well, one of them's greater than, one of them's less than. Yeah, which one is which, right? So knowing the names of the symbols so that we can communicate precisely. It's also about, at the end of a problem, specifying the units of measure. It might be 8. 8 what? 8 meters or 8 meters per second, right? So we do need to specify the units of measure. That includes, we're going to be doing a lot of graphing this year, and it includes labeling our axes so that we know what is being measured on the x-axis and the y-axis. It is calculating accurately and efficiently, yes. But do you see how all of those other things were listed before that? Express numerical answers with the degree of precision appropriate for the problem. Rounding when necessary for the situation. So it's kind of interesting. Remember, go back to circles. Remember when we were doing circles last year and we would involve pi and now there's like 1,000,000 decimal places, right? Like, well, how many of them do I need? And so being able to choose for yourself how many is appropriate, what is going to be the most precise for the specific problem. So one thing that I would like us to understand is precision is not just accuracy, right? It is being specific. It's being clear. And so when I summarize attend to precision as making sure we have the ability to communicate precisely, understanding that precision or communicating precisely does involve specific and clear terms. This is my favorite example when it comes to precision. You guys saw it last year. Let's see if you can even remember without calling out what shape is the one that belongs here in this missing space. You can see this shape, there's a blank. What is the shape that belongs here? Let's go quiet think time so that people in the video have a chance to think for just a second. Okay, what is the name of that shape that belongs there? Hannah? Yeah, we want to say it's a square, right? Because a square has what? 4 sides. But are all 4-sided shapes squares? No. And so understanding the precise definition of a square and the precise definition of the word that we're actually looking for, that's where it gets to be an example of Math Practice 6, attend to precision. What do you think, Bethany? Yeah, it's a quadrilateral. And we could list a whole bunch of others. There's rhombuses, there's rectangles, there's parallelograms and trapezoids. And so when we really look at just what is the information that I know, all I know is that this has 3 sides. We don't know any information about the angles. We don't know any information about the side lengths. This one, all I know is that there are 5 sides. No information about side lengths or angles. And all I know here is 6 sides. So of course the one that belongs in the missing space is a 4-sided figure. But now it's time to really think, what is that 4-sided figure actually called? It's a quadrilateral, exactly. And so understanding that a quadrilateral is any 4-sided figure and not just one specifically with the unique characteristics of right angles and congruent sides. Any 4-sided figure would do. Okay, let's move on to Math Practice 7. I really like Math Practice 7, and we actually use it a lot. We just don't always realize that we're using it. So Math Practice 7 is look for and make use of structure. Let's just quickly read through here. It says, look closely at mathematical relationships to identify the underlying structure. But again, what does that mean? Look for and make use of structure. Recognizing a simple structure within a more complicated structure. We can see complicated things, such as some algebraic expressions, as a single objects or as being composed of several objects. Making use of structure often requires students to decompose and compose numbers, shapes, expressions, equations, etc., to see it from a different point of view or to make use of the various pieces of the whole structure. I'm going to go back to a problem that you probably haven't seen since maybe 5th or 6th grade. So, if I asked you to find the area of this perfectly drawn shape, what would you probably do with that? What does that shape look like? Ryan? Yeah, it looks like a rectangle and a triangle. So we do this naturally. We just don't always realize that we're making use of the structure. This shape is composed of a triangle on top of a rectangle. So find the area of one shape, then find the area of the other shape, then recompose them back together. We took it apart, treated them separately, bring them back together. And so with that same idea in mind, let's first write down the way that we can think about this. Again, these all come from Robert Kaplinski. Simplify problems. by using their structure. But again, I really think that that word structure, if we don't have a good solid understanding of what it means, then this is still a confusing thing. So simplify problems by using their structure, specifically to decompose. It means we're going to break up. Or compose, which means to put back together. The parts of the problem. Now I had you begin class by solving a simple two-step equation. You're going to be moving on to multiple step equations for our first unit here in 8th grade. So here's one of those examples, and it might feel a little bit intimidating out of the gate. But if we look at the structure of it, I would like to point out we really can just decompose this problem into this big, ugly thing plus 12. Now, doesn't that become maybe a problem that a 4th grader could do? Something plus 12 is 62. What is that something? What does that have to be in that red box? Xander? Yeah, it would have to be 50, right? Because 50 plus 12 is 62. So what do I now know? That this red box is 50. Look at how much simpler we made the problem just by breaking it apart and understanding that one thing. And we can continue on with that same sort of idea, which is honestly, I think, how a lot of you guys looked at the equation if you forgot that flow map for our Warmup. So now I'm seeing, hey, wait a second, this is just 5 times something. 5 times something is 50. So what if I rewrote that problem now to be 5 times something is 50? What would that something have to be? Yeah, that something is obviously going to be 10. So what do I know about this something and this something? They're the same thing. So I can now decompose and recognize x minus 3 then would have to be 10. So what is that x going to have to be? Yeah, that x is going to have to be 13, because 13 minus 3 is equal to 10. So you can handle a very complicated equation that you really haven't been taught how to handle just by breaking it down, looking at that structure. Here's another one. If I asked you to do this mentally, 52 times 8. Most of us, not always, but a lot of times we would break this up mentally and not stack it doing this algorithm. What we would do mentally is we'd recognize, hey, wait a second, can't we just do 50 times 8? And then 2 times 8? And then just add those together? And if we needed to further decompose 50 times 8, we could also then further think, 50 times 8, I could actually think about that as 5 times 8, which I then am going to multiply by 10. Right? So that's what we're doing when we're decomposing things, when we're doing some of these mental math strategies. That's Math Practice 7. We're making use of the structure of mathematics, how things are built. That way we can take them apart and use them in their pieces. And our last math practice is Math Practice 8. Look for and express regularity in repeated reasoning. A lot of times students get confused between Math Practice 7 and Math Practice 8. I don't know why. I don't know if it's because they both say look for. But Math Practice 8, the key word here is this repeated reasoning. Notice if reasoning is repeated and look for both generalizations and shortcuts. You guys looked for those generalizations. Go back to when we did ice cream scoops. Remember the ice cream scoop problem? You guys were looking for generalizations, like, wait a second, does this work every time? Does this work if there's 7 flavors? Does this work if there's 10 flavors? What if there's 50 flavors? Those are generalizations. But the key thing about Math Practice 8 is that repeated reasoning is patterns. repeated reasoning is just a fancy way of saying, are you seeing any patterns? Are you seeing anything again and again and again that you can reuse? Math practice 8 is also reusing strategies that have worked for similar problems in the past. And so I think this math practice is all about simplifying problems by noticing patterns. Simplify. For example, I have 5 pounds of holiday fudge that I need to separate into 11 containers for gifts. And no, you don't get to use calculators, you get to do it the old-fashioned way. We did have to do some of this last year, near, I don't know, third-ish term maybe. I have 5 pounds of holiday fudge that I need to separate into 11 containers. What am I really asking? 5 divided by 11. 5 is going to be split up into those 11 groups, and so I have a problem like this. Can 11 go into 5? No. Can 11 go into 50? And I'm actually going to ask it the way that I like to teach long division. I don't teach long division. It's not part of the middle school curriculum. But if I were to teach it, I wouldn't say, can 11 go into 50? Because we forget that we're dividing. I like to ask instead, if I have 50 things and I'm splitting them into 11 containers, how much would go into each container? Yeah, it's going to have to be 4, right? That means if I have those 50 things, 4 in each of 11 containers, that means I've used 44 of those things, right? Have I used all of them? No, there's still 6 left. You know the drill. We're going to annex another 0 and bring it down. And again, I don't like asking, can 11 go into 60? Think of it instead of, I have 60 things that I'm going to put into 11 containers. How many is going to go in each container? It's going to have to be 5 this time. So 5 in each container. That means I've used 55. Have I used all of those things? Nope. How many do I have left? 5. So let's annex another 0. All right. I have 50 things that I'm going to split up into 11 containers. How many can go in each container? You get the idea, right? You're already seeing it, and that's the point of this. Do you want to continue dividing forever and forever for the rest of your life? Because this is never going to end, right? So this is where that math practice 8 comes in. Are you noticing a pattern with this algorithm, with what's happening? And so we reach this point where we're like, okay, I think I know what's going to happen. This means we're going to have 0 and 45 repeating. Okay. That is your math practices. These are the things that good mathematicians do, and as we continue to learn new math, we're going to continue to learn how to be better and better mathematicians. So I'd love for, throughout this year, for you to continue to practice these standards. What questions do you have for me? Okay, please don't forget to complete your homework assignment in Canvas regarding these 8 math practices. That's it for today. Thanks for watching. We'll see you next time.